Okay, my filter press test is just about up. In other words, my 30 minutes have just about expired. I'm waiting on my timer here to tell me when the 30 minutes is up. I have collected about 6 milliliters of filtrate in my graduate cylinder. I monitored periodically the gauge to make sure that it was holding the 100 psi. I had to turn the pressure up just a little bit one time. It got down to about 90 psi, something like that. So I bounced it back up to 100. And it has maintained that. So I don't have any leakages in the system anywhere. So that's a good thing. So what I'm going to do now is, at the completion of the test, I'm going to depressurize things, collect my filtrate, see what kind of filter cake we have, what kind of wall building capabilities that this mud has, and clean things up, and that will be the conclusion of the test. So let me check the filtrate one other time. It looks like I'm actually still collecting filtrate. Some people cheat. Yeah, right at 6 milliliters. Some people cheat and they run a 7.5 minute filter press test, and that is really frowned upon. The reason being that initially you collect an inordinately large amount of filtrate because you haven't deposited a filter cake. There's my 30-minute timer. So if you collect a large amount of filtrate initially and you multiply that by 2, you're just compounding the error. So since my 30-minute test is over, I'm going to depressurize the system. The first thing I do is I take pressure off of the cell. I do that by turning my T-screw on my regulator counterclockwise. As I mentioned earlier, that diaphragm is depressed, so I am flattening the diaphragm out. It just released. You can feel when it loosens, and that is loose. So air cannot go from the CO2 inlet side to the outlet side. So I still have pressure in the line here, however, between the regulator and the fluid level, the top of the fluid level in the cell. So I have to get rid of that some way. The way I get rid of that is with my bleeder valve. And you may be able to hear this pop, but whenever I pull this out, you can hear that. That released the pressure from here through here. So basically the system is now safe to open up. I want to be very careful of 2 things. Number one, I don't want to forget my graduate cylinder here and my filtrate that I have collected. As I say, about 6 milliliters of filtrate, and this is coffee colored. So if I'm running a chloride analysis, it's going to be hard to see that brick red endpoint with this. I'll have to treat it so that I can see it, or use a chloride probe or something of that nature. So I've depressurized the system here. I have depressurized this. So now I'm ready to disassemble the cell. So I'll have to be very careful when I do this because I've got this regulator assembly on this side. Whenever I loosen the T-screw on top, if I'm not very careful, this will fall over and make a humongous mess right on my feet. So I don't want to do that. So I'm going to hold it down on the back side and loosen the T-screw on top, sufficient so that I can pull everything out. I take the top cap off, and all of that looks good. There is my drilling fluids that did not go through the filter on the bottom. I'm going to set this off to the side. I'm going to pour this back into the vessel that it came out of. And there is my filter cake on the bottom of the cell. So I simply loosen this. I put the cell cylinder in the sink. Now I've got my gasket, my filter paper, and my filter cake. I want to get the gasket out, so I just remove that with a spatula. Spatulas are the handiest implements in a laboratory. Now I've got my filter cake on top of my filter paper. So to retrieve that, and you do it very carefully, you don't want to destroy the paper or the filter cake. So lift that out again with the spatula. There is the 60 mesh screen in the bottom of the filter press cell. I'll put that in the sink for cleaning up later. So here is my filter cake that has been deposited. It looks to be about maybe a 32nd of an inch thick. Just to be on the safe side, I'll gently wash this, get rid of any extraneous mud that may be laying on top of it, and all of that is a filter cake. In some cases it may be very thick and fluffy. In other cases it is thin, hard, and rubbery like this, and that's how we describe the filter cake. Thin, rubbery, firm, loose, thick, whatever, all those scientific terms. There's no really good way to describe it. You just describe what it looks like, and also you can see what it feels like. That's a good filter cake right there. That would make a good wall building, wall sealing filter cake on the wall of a hole in the downhole environment. And losing only 6 milliliters of filtrate, that indicates that this supplied a good seal, because 6 milliliters of filtrate is really not bad. When you get upwards of 15, 20, 25 milliliters, then you probably have a problem, and you might want to look at that. But it depends on the fluid. It depends on how many cuttings you have, what type of solids you have, and things of that nature. So what I'm going to do from here, basically my test is over with. Next thing I will do is clean everything up, put the filter press cell back together, and I will be in business for the next test. But as I mentioned earlier, cleanliness is the main thing to do here. You want to make sure that you're ready to go for your next test, and if you get in the habit of cleaning things at the end of each test, then you can't go too wrong with your next test. But this basically is a low pressure API filter press using CO2 bulbs as pressurization devices. And as I mentioned, this is OFI part number 140-30. This is our most popular filter press that we sell, and we have sold thousands and thousands of them. These filter press are all over the world, in every mud lab, in every offshore platform, onshore platform. They're very, very extensively used. And once again, this is an API filtration test. Thank you very much.